Okay, so let's just dive right in. While we're all down here going about our day, something wild is happening. Silently, hundreds of kilometers above our heads. A new kind of war is taking shape. A battle for the ultimate high ground. And the weapons being developed are, well, they're like nothing we've ever seen before.
So that's the big question, right? It's what military planners are losing sleep over right now. And the answer? It's all about invisible beams of energy, it's about swarm tactics, and it's about a super high-stakes tech race that is completely rewriting the future of conflict. So what changed? Why now? Honestly, it boils down to one word: proliferation. The fact that we now have these massive constellations of small satellites in low Earth orbit, it has completely changed the rules of the game up there. You see, for decades, the model for space warfare was pretty simple. You had a handful of massive, incredibly expensive satellites. Think of them like the key bridges into a city. If you could take out just one of those, you could potentially blind an entire military's communication or surveillance network. A single point of failure. But that's all changed now. A network like Starlink, with its thousands upon thousands of interconnected satellites, is a totally different beast. It's not one big bridge, it's a whole city with 1,000 different streets. Taking out one or two satellites, it's like a minor traffic jam. The data just reroutes, and the network as a whole barely even blinks. It's resilient by design. And you have to look at this from a military strategist point of view. For planners in the People's Liberation Army, for example, Starlink isn't just for streaming movies in the middle of nowhere. No way. They see it as a powerful strategic asset that can provide resilient communications on the battlefield, help with intelligence gathering, and maybe even be used to engage other satellites. And that perceived threat, well, it's driving a massive technological response. Which brings us to the Challenger's move. See, if you can't just pick off satellites one by one with missiles anymore, you need a totally different kind of weapon. One that's designed specifically to take on this new, decentralized swarm. A nightmare for Starlink. I mean, that's literally how some media reports have described this new tech coming out of China. It's a pretty stark phrase, and it really gets at how serious this development could be. So, what is this thing? All right, meet the TPG-1000Cs. It's not a laser, not a missile, it's a ground-based, high-power microwave weapon. The whole idea is to shoot a powerful, totally invisible beam of energy from the ground up to a satellite and just fry its electronics. And the power level here is just staggering, 20 gigawatts. Now, to put that into perspective, experts figure you only need about 1 gigawatt to seriously disrupt a satellite in low Earth orbit. This thing has a massive power surplus, and it's designed to just punch right through the atmosphere and any shielding to get the job done. But it's not just about raw power. The TPG-1000CS is a huge leap forward across the board. It's way more powerful than older systems, sure, but it's also dramatically smaller, lighter, and get this, it can fire continuously for a full minute. Older models could only manage a few seconds at best. That's a game changer. This right here just shows you the huge evolution in this technology. I mean, we've gone from the era of giant, multi-billion-dollar chemical lasers that had to be mounted on a jumbo jet to compact mobile electronic weapons that you can literally put on the back of a truck. They become smaller, way more efficient, and a whole lot more practical. Okay, so how in the world does an invisible beam of energy actually kill a satellite? It sounds like science fiction, but the physics are very real. Let's break down how this kind of attack actually works. So the energy can get inside the satellite in basically two ways. You've got your front door attack, which is kind of elegant. It uses the satellite's own communication antenna as a welcome mat to send a massive energy surge straight into its brain. Then you have the backdoor attack, which is more of a brute force approach, just blasting so much energy at the satellite that it leaks in through tiny cracks, seams, or unshielded ports. And because these systems are getting so small and efficient, you can house them in something as ordinary as a shipping container. Just think about that. It makes them mobile, incredibly easy to hide, and you can deploy them just about anywhere in the world really quickly. Now, an attack doesn't always mean total destruction. There are levels to this. At the low end, you have what's called an upset. Think of it like a temporary glitch. The microwave beam scrambles the satellite's electronics, but once the beam is off, it kind of shakes it off and goes back to normal. Okay, one step up from that is lockup. This is more serious. The satellite systems just completely freeze. It's basically a floating brick until operators on the ground can send a command to reboot it. And in the middle of a conflict, that downtime could be critical. And then you have the end game, latch up.
This is the whole point of a weapon like the TPG-1000Cs. The energy pulse is so intense that it physically burns out the microcircuits. We're talking permanent, irreversible damage. It's a hard kill. The satellite is now just a very expensive piece of space junk.
So, of course, this kind of offensive leap kicks off an equally intense race on the defensive side. I mean, how do you protect thousands of satellites from an invisible weapon that moves at the literal speed of light? And engineers are not just sitting around, believe me. This quote here from MIT's Lincoln Laboratory points to one of the coolest solutions being worked on, using advanced manufacturing to basically print custom shields right onto the satellite's most sensitive parts. So defending these things really comes down to a three-pronged approach. First, you design the circuits to be tougher from the get-go. That's rad hard by design. Second, you use techniques like 3D printing to add custom shielding right where it's needed most. And third, you use smart software that can actually detect and correct errors from an energy attack as they happen in real time. All right, let's zoom out for a second and look at the big picture here. This constant cat-and-mouse game of attack and defense, it's creating this brand new invisible battlefield in orbit where, frankly, there are very few established rules.
And to really get why these weapons are being built, you've got to understand a strategic concept like Wishe. It's often translated as deterrence, but it's more than that. It's about having the ability to strategically coerce an opponent, to make them think twice about getting involved in a conflict by holding their critical space assets at risk. An EGPM weapon is the perfect tool for that kind of strategy.
So, at the end of the day, the ultimate response isn't just a better shield or even a better weapon. The real race now is about building your own resilient networks. And that's exactly what's happening. China is moving fast to build its own massive constellations, like SatNet and G60, to mirror the exact same decentralized strength that makes Starlink so tough. In this new game, it turns out that having a massive swarm is both the target and the defense. Which leaves us with this final, really critical question. Think about it. An attack with a microwave weapon leaves no shrapnel, no debris trail. It could just look like a mysterious electronic failure. In a world where it's incredibly hard to prove who did what are the rules of engagement? How do you respond to an attack you can't even see? And what does that mean for all of us down here who depend on these fragile networks every single day?